The morning of December 7th, 1941, dawned clear over Pearl Harbor as two American pilots rushed to their fighter aircraft, preparing for what they believed would be routine patrols. Lieutenant Phil Rasmussen, already in his pajamas, and Lieutenant Howard Aswepia Cody, clad in his underwear, would become among the first American pilots to engage Japanese aircraft in aerial combat. Their mount, the Grumman F4F Wildcat, an aircraft that would quickly prove both the salvation and the bane of American naval aviation in the Pacific War. As Japanese Zeros screamed overhead, establishing air superiority with devastating efficiency, American pilots quickly learned that their Wildcats, while sturdy and reliable, were outclassed in nearly every aerial performance metric by the elegant and deadly Mitsubishi A6M Zero. This contrast would define the early months of the Pacific War, forcing American aviators to develop new tactics and strategies to overcome technological disadvantages. The Wildcat and Zero would clash in the skies above the Pacific for nearly 4 years, their performances and modifications reflecting the evolution of naval aviation doctrine and the industrial might of both nations. The story of these two aircraft is not merely one of technical specifications or kill ratios, though both would be impressive statistics. Instead, it's a tale of how technology, tactics, and human determination combine to alter the course of naval warfare forever. The Wildcat, built to replace older biplane fighters, would prove that sometimes the underdog can win through superior tactics and engineering robustness. The Zero, engineered as Japan's ultimate naval fighter, would demonstrate that technological superiority alone cannot guarantee victory when facing an industrial giant with unlimited resources and the will to adapt. The design philosophies behind these two aircraft reflected the fundamentally different strategic approaches of their respective nations. The F4F Wildcat emerged from Grumman's engineering philosophy of if it ain't broke, don't fix it. American designers believed in building rugged, reliable aircraft that could take punishment and return their pilots home safely. The Wildcat was essentially an evolution of proven naval fighter concepts, incorporating lessons learned from previous aircraft like the F-2 Buffalo while prioritizing pilot survivability and operational reliability. The Mitsubishi A6M Zero, conversely, represented the pinnacle of Japanese lightweight fighter design philosophy. The Japanese naval doctrine emphasized maneuverability, range, and offensive capability, believing that decisive aerial battles would be won through superior pilot skill and agile aircraft rather than defensive armor or heavy firepower. The Zero was designed to be the ultimate turning fighter, capable of outmaneuvering any opponent while maintaining an impressive range that would allow Japanese pilots to engage far from their carriers. These contrasting approaches stemmed from different industrial capabilities and strategic considerations. America possessed vast industrial resources and could afford to build sturdy aircraft that prioritized pilot safety, knowing they could produce replacements quickly if losses occurred. Japan, with limited industrial capacity, focused on creating aircraft that could maximize individual pilot effectiveness while minimizing resource consumption. The Wildcat weighed over 6,000 pounds empty, while the Zero tipped scales at just 3,700 pounds, a difference that would prove crucial in aerial combat performance. At first glance, the technical specifications reveal the fundamental differences in design approach. The F4F Wildcat measured 28 feet 10 inches in length with a wingspan of 38 feet, making it a substantial aircraft that conveyed a sense of solidity and strength. Powered by a Pratt & Whitney R1830 twin Wasp engine producing 1,200 horsepower, the Wildcat could reach maximum speeds of 331 miles per hour at 21,300 feet. Its service ceiling reached 34,200 feet, while its range extended to 770 miles, providing reasonable operational flexibility for carrier-based operations. The Mitsubishi Zero presented a stark contrast in every measurement. At 29 feet 7 inches long with a wingspan of 39 feet 4 inches, the Zero appeared similar in size but weighed dramatically less. The Saki 12 engine produced 940 horsepower, nearly 260 horsepower less than the Wildcat's engine. Yet the Zero could achieve maximum speeds of 331 miles per hour. identical to the American aircraft. This speed parity, achieved through weight reduction rather than engine power, highlighted the Zero's superior power-to-weight ratio and aerodynamic efficiency. The Wildcat carried 6 at 0.50 caliber machine guns, mounted 3 per wing, providing substantial firepower while maintaining simplicity of operation and ammunition supply. The Zero initially carried 4 0.303 caliber machine guns in the wings, supplemented by 2 20mm cannon in the fuselage, creating a devastating combination of high-velocity machine gun fire and explosive cannon shells. The American choice of heavier 0.50 caliber bullets provided better penetration characteristics, while the Zero's combination offered superior firepower with less weight penalty. The true test of any aircraft comes not in theoretical specifications but in actual combat performance, and here the differences became immediately apparent to American pilots. The Zero possessed extraordinary maneuverability, capable of sustained vertical climbs and tight turns that left American pilots gasping in amazement and frustration. The Wildcat, while reasonably maneuverable for a naval fighter of its era, simply couldn't match the Zero's sustained turn rates or climb performance. American pilot Lieutenant John Apape Boyington, later commanding the famous VMF 214, a Black Sheep Squadron, described his first encounter with a Zero. The enemy plane turned inside our circles like we were standing still. We'd be doing our tightest turn at 150 knots, and the Zero would just cruise past us at 120 knots, completely in control. This sentiment was echoed by dozens of American pilots who found themselves outmaneuvered by the seemingly effortless agility of Japanese aircraft flying. However, the Wildcat possessed one crucial advantage that American pilots quickly learned to exploit: survivability. The aircraft's construction emphasized pilot protection through self-sealing fuel tanks, armor plating around the cockpit, and redundant structural elements. Many American pilots survived Zero attacks that would have destroyed lighter-built aircraft, returning to their carriers bearing multiple bullet holes and extensive damage. The Zero, while incredibly agile and lethal when attacking, proved vulnerable to return fire due to its lightweight construction and minimal protection for critical systems. A single well-placed 0.50 caliber bullet could disable critical flight controls, puncture fuel systems, or damage the pilot in a way that would have been survivable in a more robust aircraft. This fundamental difference in survivability would prove decisive in the later stages of the war. American pilots quickly learned that fighting the Zero on Japanese terms led to certain defeat. Traditional fighter tactics emphasizing turning combat favored the Zero's superior agility, leading to devastating losses for American forces in early 1942. The solution required completely rethinking fighter tactics and developing new methods of engagement that played to Wildcat strengths, while minimizing weaknesses. The answer emerged as the Thach Weave, developed by American naval aviator John Thach after witnessing Zero superiority in combat. This tactic involved 2 aircraft flying in close formation, coordinated to provide mutual protection during turning engagements. When a Zero attempted to engage one aircraft, the other would provide covering fire, preventing the Japanese pilot from completing his attack. This simple but effective tactic saved countless American pilots and their aircraft during the crucial early months of the Pacific War. Additionally, American pilots learned to exploit the Zero's weaknesses through specific tactics. Diving attacks that emphasized speed over maneuverability allowed Wildcat pilots to engage the Zero on their own terms. The American aircraft's superior diving speed meant that American pilots could dive away from engagements when necessary, forcing the Zero to give chase at slower speeds. When combined with the Wildcat's superior dive speed and the Zero's lighter construction, these tactics often resulted in successful escapes from hopeless situations. The American approach also evolved toward energy tactics that emphasized altitude and speed advantages. Instead of engaging in turning dogfights that favored the Zero, American pilots learned to use their aircraft's superior dive and acceleration to gain strategic advantages before closing for attack. This approach required more skill and coordination than traditional dogfighting, but proved effective against even the most skilled Japanese pilots. The operational history of both aircraft reflects the broader trajectory of the Pacific War. During 1942, the Zero dominated aerial combat, shooting down American aircraft with apparent ease while establishing Japanese air superiority across the Pacific theater. Aircraft carriers like the Lexington, Saratoga, and Enterprise relied heavily on F4F Wildcats to provide fighter protection, and losses were heavy during this period. The Battle of Coral Sea in May 1942 marked one of the first major carrier vs. carrier engagements of the war, with Wildcat pilots engaging Zeros defending Japanese aircraft carriers. While American losses were substantial, the engagement demonstrated that Wildcats could achieve tactical success despite their technological disadvantages. The battle resulted in both carrier forces withdrawing, with Japanese losses including the light carrier Shoho and significant aircraft losses. The pivotal moment came at Midway in June 1942, where F4F Wildcats achieved their greatest success against Japanese carrier Aviation. Despite suffering heavy losses during the initial Japanese strike, Wildcat pilots inflicted severe damage on Japanese aircraft, contributing significantly to the destruction of 4 Japanese fleet carriers. American aircraft losses were high, but the tactical success justified the sacrifice and marked the turning point in the Pacific War. As the war progressed, the Wildcat continued to serve in various roles, while newer American aircraft like the F6F Hellcat began replacing it in frontline service. However, the Wildcat proved its worth in multiple campaigns, from the Solomon Islands to the Aleutians, where its rugged construction and reliable performance made it ideal for demanding operational conditions. The aircraft served in fighter attack and even photo reconnaissance roles, demonstrating its versatility and robustness. Each aircraft possessed design characteristics that reflected their designers' priorities and the strategic considerations of their respective nations. The Wildcat's design emphasized pilot survivability and operational reliability, characteristics that proved invaluable during the brutal early months of the Pacific War. The aircraft's ability to absorb damage and return pilots safely to their carriers meant that American pilot training programs could gradually improve their effectiveness through combat experience rather than high casualty rates, depleting pilot pools. The Wildcat's construction featured strong, sturdy airframe components that could withstand significant damage without catastrophic failure. Self-sealing fuel tanks, pilot armor protection, and redundant flight control systems ensured that even severely damaged aircraft could often return to base. American maintenance crews found Wildcats relatively easy to repair in field conditions, crucial for operations from forward island bases with limited technical support. However, the Wildcat's emphasis on survivability came at the cost of performance. The aircraft's weight penalty limited its maneuverability and climb performance compared to the Zero. American pilots required significantly more skill and training to effectively engage Zero pilots in combat, relying on superior tactics and coordination rather than aircraft performance alone. The aircraft's limited range also restricted operational flexibility compared to the Zero's impressive endurance capabilities. The Zero's design excellence manifested in its incredible maneuverability, superior climb rate, and exceptional range. Japanese pilots could operate effectively from widely dispersed bases, maintaining air superiority over vast areas of the Pacific. The aircraft's lightweight and excellent power-to-weight ratio meant it could outclimb, outturn, and outmaneuver virtually any Allied fighter it encountered in 1942 and early 1943. Yet the Zero's design excellence came with significant compromises. The aircraft's lightweight construction and lack of protective armor made it vulnerable to return fire and pilot injury. Japanese industrial limitations meant that new aircraft production couldn't replace losses quickly once American industrial capacity came fully online. The Zero's design philosophy, optimized for early war conditions, became increasingly obsolete as newer American fighters emerged with superior performance and protection. The contrast between the Wildcat and Zero fundamentally shaped the development of naval aviation tactics and aircraft design throughout the Pacific War. American experiences with the Wildcat demonstrated that survivability and tactical flexibility could overcome technological disadvantages through innovation and adaptation. The successful development of tactics like the Thach Weave and energy fighting techniques established new paradigms for aerial combat that would influence fighter doctrine for decades. The Wildcat's performance also highlighted the importance of pilot training and experience over raw aircraft capability. American pilot training programs, which emphasized individual skill development and tactical innovation, proved more valuable in the long run than technological superiority alone. The gradual improvement of American pilot effectiveness through combat experience demonstrated the value of investing in human factors as much as technological development. Japanese reliance on the Zero's superior performance initially provided enormous tactical advantages, but ultimately became a liability as the war progressed. The aircraft's design limitations became increasingly apparent as newer American aircraft emerged with superior performance characteristics. Japanese inability to replace aircraft losses quickly due to industrial constraints meant that veteran pilots, their most valuable asset, were killed faster than replacements could be trained. The Wildcat Zero comparison also influenced Allied aircraft design priorities. American engineers learned valuable lessons about balancing performance with survivability, while British and other Allied nations adapted their fighter requirements based on Pacific War experiences. The emphasis on pilot protection that characterized American aircraft design throughout the remainder of the war can be traced directly to lessons learned during Wildcat combat operations. The technological legacy of both aircraft extended far beyond their actual combat service. The Wildcat's design philosophy influenced later American naval fighters, emphasizing pilot protection and aircraft survivability. The F4F's success in developing effective tactics against superior enemy aircraft established principles that influenced fighter training and doctrine development throughout the war. The Zero's performance characteristics, while ultimately insufficient to ensure Japanese victory, demonstrated the potential of lightweight fighter design and advanced aerodynamics. Post-war analysis of captured Zeros provided valuable insights into Japanese aviation technology and engineering techniques that influenced American aircraft development. The captured aircraft also revealed Japanese industrial capabilities and limitations, informing Allies' strategic planning. Both aircraft evolved significantly throughout their operational careers. The Wildcat underwent numerous modifications, improving its performance and capabilities, demonstrating American industrial flexibility and continuous improvement. Later Wildcat models featured more powerful engines, improved armament, and enhanced avionics systems that gradually improved their combat effectiveness against emerging Japanese aircraft designs. The Zero also evolved throughout the war, with later models featuring more powerful engines, improved armament, and enhanced pilot protection. However, Japanese industrial limitations meant that these improvements often came too late to significantly impact combat effectiveness. The aircraft's fundamental design characteristics remained largely unchanged throughout its service, limiting its ability to compete with newer Allied designs. Conclusion. Symbols of an era. The comparison between the F4F Wildcat and A6M Zero represents more than just a technical analysis of two aircraft. It embodies the contrasting philosophies, industrial capabilities, and strategic approaches that shaped the Pacific War. The Wildcat, representing American engineering pragmatism and industrial might, proved that sometimes the most effective weapon is one that can absorb punishment while delivering reliable performance. The Zero, embodying Japanese precision and efficiency, demonstrated that technological superiority alone cannot overcome resource limitations and strategic overextension. The Wildcat served in multiple roles throughout the war, from frontline fighter to trainer to liaison aircraft, proving its worth through versatility and reliability. It earned the nickname a murderous Wildcat from Japanese pilots who found American aircraft difficult to destroy despite apparent victory in combat. The aircraft's contribution to America's eventual victory in the Pacific cannot be overstated. While slower and less maneuverable than contemporary opponents, it provided the foundation upon which American naval aviation mastery was built. The Zero established new standards for fighter aircraft performance, proving that lightweight and maneuverability could overcome apparent disadvantages in engine power and structural robustness. Its early dominance of Pacific skies shocked American planners and pilots, forcing rapid adaptation and innovation that would ultimately lead to superior aircraft designs and tactics. The aircraft's eventual obsolescence reflected not a failure of design excellence, but rather the inexorable impact of American industrial capacity and technological innovation. Perhaps most importantly, these two aircraft symbolize the human element that ultimately determines victory in aerial combat. American pilots flying Wildcats learned to overcome technological disadvantages through superior tactics, training, and coordination. Japanese pilots flying Zeros demonstrated that technological superiority and individual skill, while crucial, cannot overcome strategic mistakes and resource limitations. The lessons learned from these aircraft influenced fighter design and tactics for decades, establishing principles that continue to influence modern military aviation development. The Wildcat and Zero fought their final battles long ago, both aircraft having been retired from active service decades ago. Yet their legacy continues through the aircraft that succeeded them and the lessons they taught to both nations. The Wildcat demonstrated that sometimes the underdog can win through persistence and innovation, while the Zero proved that technological excellence must be supported by sustainable industrial capacity and strategic wisdom. Together, these two aircraft changed the course of aerial warfare and left an enduring mark on military aviation history that extends far beyond their actual operational service. In the skies over the Pacific, where young men and flying machines decided the fate of empires, the Wildcat and Zero wrote one of the greatest chapters in aviation history, a story of innovation, adaptation, and the eternal struggle between technological superiority and human determination that continues to shape our understanding of aerial combat today.